right, I think we'll probably go ahead and get started. We may still have few people roll in, but that is just fine. I wanted to take a moment to welcome everyone today to Improving's virtual lunch and learn. We do have an exciting speaker and an exciting talk today. I have the honor of introducing John. John has been a technical director here at Improving in Atlanta. He's been with Improving for almost 9 years. Overall, John has 15 years of experience across multiple disciplines from network engineering, mobile and web application development, platform engineering, and DevOps. Currently, he's focusing on leading client delivery teams to architect and deploy solutions using modern application architectures, cloud services, and other emerging technologies. So we have an expert on the line. Today, we'll be discussing a blueprint for your infrastructure. And John, I'd like to turn it over to you to go ahead and get us started.
Fantastic. Thank you very much, Emily. So as Emily mentioned, today's talk is a blueprint for your infrastructure. This is part of Improving's June platform engineering series. So we've got a couple talks that you can find here live throughout this month and the coming weeks, or see replays here on our YouTube channel when we publish this out. But excited to be here and talk to you today about Terraform and infrastructure as code. So quick agenda, just an overview of what is infrastructure as code, why it's important and how it can be used, an introduction to Terraform, why Terraform over some other tool sets that we'll talk about. We'll then go into specific key Terraform concepts with the ultimate goal of this talk today is to ensure viewers have the tools and knowledge to use Terraform in their personal and professional projects. So what is IAC? So infrastructure as code is the management of infrastructure. So we're talking things like networks, virtual machines, load balancers, connection topologies that connect all of that together in a descriptive model. And the big thing is it uses the same versioning as the team uses for source code. So all of the definition of your infrastructure can be committed, audited, using your same pull request methodologies to get code in there. So to avoid that situation where something just all of a sudden isn't working or somebody made a change to a virtual machine setting, so that underlying infrastructure now has the same auditability and tracing as the source code that we've kind of as developers been used to. So like the principle that the exact same source code generates the same binary, these infrastructure as code tools, the idea is that the exact same code will generate the same environment every time it's applied. So just to reiterate that and rephrase that, so some of the core concepts are it's defined in code. So your infrastructure is now coded as opposed to just kind of set up on the fly and left there. That code is then stored in source control, and all of the same rigors that we apply to development code or application code are applied to our infrastructure as code as well. It's independent and consistent, so it doesn't change unless we have traceability of what changes were made, and we've got a history of all of the changes. And then the application of that code is consistently applied. The big benefit of this is things like automated deployment. If I can code my infrastructure, I can build this model of what my environment should look like into systems that automatically deploy it, right? They can deploy it repeatably. So I've got the freedom to spin up and tear down environments with the assurances that when it comes up, it should be just the way that I coded it in the exact same manner weeks, months later. Consistent environments. So if I'm building a dev or test or QA or staging or production environment, you might replace some variables for different settings and performance levels of the underlying infrastructure. But overall, the environment that is getting created throughout those different stages or levels is consistent and consistently deployed and applied. Another big tenet is reusable components. if I've got something that is defined and I need to deploy more than one of them, there's always a chance with the point and click or having multiple people deploy a different virtual machine or different network. Each person's going to maybe do something slightly different or make a different decision. And so you might get, well, I want 10 VMs that all look exactly the same. Different developers may, or different infrastructure engineers may configure them slightly differently. Whereas this, by having a reusable component, will consistently get a VM definition that we've all agreed upon, and that same definition goes out and launched into an environment. And then the big one for me that I think is huge is the documented architecture. So by having your infrastructure in code, I can then go back and review the code to see what is the architecture of this environment, as opposed to if it's all done via either just ad hoc command line or through some of the portal tools and the cloud providers that we'll talk about. I'd have to go audit each one of those resources to see what actually is deployed, what actually is running in production, what actually is the configuration, as opposed to if it's all right here in code, it's all right there in front of me of, oh, okay, cool. The VMs in development have this CPU configuration, this much memory, this much hard disk space, and it's configured in a certain way, right? And so that's all just documented there for you to go back and understand your infrastructure, as opposed to trying to have to go poke around or, well, let me go log into that machine and see how it's configured, right? So huge benefits from IC from that standpoint. And as a developer, as a consultant, the documentation piece, as we're trying to just deliver features and deliver for our clients, that documentation piece can always kind of get pushed and pushed as we hit deadlines, right? If that documentation is built into the development process, that's a huge win and a huge benefit. So I know we're talking Terraform today, but let's talk about some other common infrastructure as code tools. And these are all great, and the cloud providers often have a built-in infrastructure as code automation standard or development language that they work with and that works really well in their environment. So in the case of Azure, we've got Azure Bicep. So I can deploy and manage resources within Azure. Same thing with Azure ARM templates, kind of the first iteration of Azure. Everything under the hood is still a Azure Resource Manager template definition. But using Bicep or ARM templates, you can code infrastructure against Azure and have all of those same tenants as IAC benefits that we talked about on the previous slide. AWS has several, the AWS CDK, the Cloud Development Kit, and AWS CloudFormation, are two IAC tools that they provide. And then Google has Cloud Deployment Manager for infrastructure as code solutions within their cloud. One of the other big ones that I actually quite like is Palomi, which is another infrastructure as code tool. And it's kind of cool in that the language is in development languages. So if you are a TypeScript developer or a C# developer, you can code infrastructure in those languages. We'll talk about some pros and cons, but really good if your infrastructure teams are developers that have really deep familiarity with those environments or those programming languages, but could be a heavier learning curve for maybe a platform engineer, somebody that maybe doesn't have a strong coding background, but still a lot of different options. The cons of Azure Bicep, Azure ARM templates, AWS CDK, AWS CloudFormation, Google Cloud Deployment Manager is those are pegged to that service provider. Can't deploy stuff to Google Cloud with Azure Bicep. But Palomi is a cross-platform solution. So that's one of the big benefits that it has. And so why are we talking Terraform today? Is that it also has that benefit along with a host of other benefits that we'll talk through in this this presentation. So again, it's cross-platform. It is driven by a provider model that we'll talk about. So different cloud providers or different infrastructure environments can write providers that allow Terraform to manage that infrastructure and deploy resources. Obviously, it's an infrastructure automation tool. It's a single binary compiled from Go. It's got a declarative syntax as opposed to some of the code-based solutions out there. And the language of the declarative Terraform files is the HashiCorp configuration language, HCL. I'll show you some examples of that and talk through that as we get further into this presentation. So that's kind of what Terraform is. Why Terraform? So I've mentioned some of them, some of the big reasons before. It's the multi-cloud support. And no matter what cloud that you're deploying to or what environment, because it's all of the configuration files are that HashiCorp configuration language, it's the same syntax across all of the providers. So if I want to quickly deploy resources to Azure or AWS or Google Cloud, or you can see here this screenshot here on the right, the top one is the provider registry, and that's just a handful of the hundreds that are available. That syntax to deploy resources is the same across cloud providers, right? Now, some of the options and parameters that you pass into a Azure virtual machine as opposed to an AWS EC2 instance might be different and specific to that environment, but the syntax and the coding language and the constructs and rules are all the same and consistent across cloud providers. It's a mature tool with extensive plugins and community support. So the bottom screenshot here is showing the module library. We'll talk about modules in a little bit, but they have a library of Terraform developed and provided, partner developed and provided, as well as community developed and provided modules that allow you to deploy a resource type and not really have to reinvent the wheel on some of the properties and the common ways that you would deploy that if they've been packaged up into a module. It's this module deploys an Azure virtual network with different subnetting and different properties that I would look at, or firewall rules or network security groups. I can go out in the community or through Azure and find a module that sets up a virtual network with all of those settings in it, as opposed to, or just using the native Azure provider and doing that step by step. But that plugin support and community support is huge for Terraform. And one of the biggest other reasons to use Terraform, and as well as any other infrastructure as code tool, is cost management. There are various tools and plugins for Terraform that if you get your code into an IAC platform, right, there are tools that can tell you, hey, you're about to apply this change to Azure or AWS. This is going to be your cost impact. And you can catch that kind of early on, even in a CI/CD pipeline or as part of a review process, that at the time I'm going to deploy this, get a warning that, hey, you're about to spin up a gigantic machine with GPU-backed processors that's going to cost you $3,000 a month, where you might only have intended to kind of deploy a more simple machine for a web workload. And you can catch that. And so by getting this stuff into Terraform, and some of the other infrastructure as code tools support this as well, you can get visibility into that cost implications ahead of time. So I want to address one kind of recent elephant in the room with Terraform, and that's been some license changes. So Terraform historically under HashiCorp was free and open source under the Mozilla license up until August of last year, where they switched to the BSL license. So the BSL license is still permissive, but prevents embedding or hosting Terraform in products that compete directly with Terraform. In addition, HashiCorp was purchased by IBM here recently, so there's been some kind of backlash a little bit, I would say, from the development community on what this licensing change means going from a fully open source to kind of not closed source, but a more restrictive license. Now, for most of the use cases for me and my clients, we never hit this, but if you want to work with improving or talk to some people internal for your specific use cases to see if you're impacted by this. And if you are, there are some other solutions and open source kind of forks of Terraform. One of them is Open Tofu that may solve that issue. But just wanted to bring that up. I'm not a lawyer, I can't give legal advice, but just to be aware of the licensing changes that are going on with Terraform here recently in 2024 at the time we're doing this webinar. So let's talk some key concepts of Terraform and how it's designed and how it works and how then you can hopefully take this knowledge and use it in your own projects or for both personal or professional usage. So the top level kind of thing that ties all of Terraform together is configuration files, right? I mentioned that there are plain text files written in HashiCorp configuration language, HCL, and they end in a .tf extension. So I've got a screenshot here that shows kind of the layout of a very, very simple Terraform file, right? And I'll get to resources here in a minute, but this is really the syntax and the definition of Terraform. You define different entities of resources, data sources. I'll talk through all of those to define your infrastructure. So in this screenshot, right, this is specific to Azure, but the same syntax would apply to AWS. In this Azure example, I'm creating an Azure resource group and then creating a storage account under that resource group. And that's all the code you need right there to create and define this Terraform file that will build this infrastructure in Azure. So I mentioned Azure, but I also mentioned before that provider model. Just providers are the plugins that Terraform uses to interact with APIs and services. So AWS, Azure, GCP, etc. So these are developed and provided by their HashiCorp partners. So Azure is huge, AWS, obviously, GCP. And these get configured in your configuration files with the necessary credentials and settings to talk to your environment. And I'll show you at the end of this, if depending on timing, I'll run through a very, very quick demo of deploying something to Azure using the Azure provider. But it contains your configuration files contain the information needed to connect to your Azure environment. And the huge thing for me, and as you get into Terraform, registry.terraform.io, the documentation behind these is really where you're going to spend your time, and I'll show you here on the next slide. Each one of these providers has their own documentation and information about the resources that you can manage using that provider, and then how to deploy them. So you've seen in the screenshots before in the configuration files with your providers, the next level is resources. What am I actually deploying inside of a cloud environment? So they're the basic building blocks of your infrastructure. They can also be cloud kind of specific things. In the case of Azure, I mentioned a resource group. That's not a infrastructure entity, but it is something inside Azure that groups your resources together. So you could create multiple resource groups to bucket different components. You can create access policies and manage security through resources as well. But primarily they represent components like virtual machines, databases, networking elements, etc., anything that you would deploy into a cloud environment. And these resources then are defined in your Terraform files with specific attributes. And I'm talked about the documentation and the provider registry. This is where you can find the exhaustive list of all of the attributes that resource supports in the Terraform logic. So here on the right-hand side in this short screenshot of the documentation for the Azure RM resource group resource. It shows you the example usage, right? At a simple level, what is the example? Or what is the simplest deployment of how you could deploy a resource group in your configuration file? And so you can see it takes a name and a location. If you scroll down through the documentation, you'll see any other optional parameters that you can add to further enrich a resource group. In this case, it's not much, but for certain other types of infrastructure, the example will give you kind of the base starting point, and then this huge exhaustive list of all of the properties that you can tweak and really get your infrastructure fine-tuned to deploy as needed. And then there's the concept I mentioned earlier about the community modules, and also partner provided modules and HashiCorp provided modules as well. So these are reusable packages of Terraform code with their own, we'll call it inputs and outputs. They help organize common infrastructure patterns, and really at their simplest level, they're implemented as a collection of configuration files in a folder. So if you've got your IAC directory and it's got some Terraform files, but then you have a subdirectory with a set of Terraform files, that subdirectory is a module. And you can sort of think of this, if you're coming from a programming background, you can sort of think of this as a method call, right? And so the way you would define this module with certain, I mentioned inputs, so those are parameters that would come into this module, and given a set of parameters, this module will create resources or do certain things based on that input, and then could then spit back an output. And that's kind of like the return at the end of a method, if you're kind of correlating this to a development C# type environment. So a simple level module, let's say, to set up a VM in a certain way that abstracts some of the logic out. You might have a VM, and the module may have the VM, the networking, any storage, all bundled into a module that you can just call and give it, hey, I want to give it a name, I want to give it how much storage space I need and what type of subnet that I want to put it in, and give it those inputs. It will go ahead and create everything as a reusable method, and then it'll return back maybe the IP address that it assigned to the VM or the fully qualified domain name to the VM, some output that then you could use later in kind of a top level Terraform code. So modules are really just, as I said, an organization strategy for infrastructure that allows you to really take advantage of that reusable, do not repeat yourself idea or pattern for infrastructure that we always try to use and try to implement in our application development. So I sort of buried the lead in putting state down here, but Terraform state is critically important, and it's the mechanism that Terraform uses to map real-world resources to your configuration. At the end of the day, Terraform is a desired state mechanism. You'll see this when I get through, show you a demo. By configuration lives in code. When I go to deploy it, Terraform will figure out what do I need to do to the infrastructure to make it look like my configuration. And it does that by looking at the state file and comparing that and querying the existing infrastructure to find the deltas and figure out what do I need to deploy, right? Stores the current state of the infrastructure and the data about resources. So if I tell it to create a new resource group, my state file will have a unique key to the resource group that was created and the properties of it when it was created, et cetera. So then the next time I try to plan or deploy my infrastructure, it's going to look at state, look what's out there, see what's different between the desired configuration and state and what's out there, and come up with a plan of what I need to change in order to make my infrastructure look like my configuration. And in some cases, ideally, it can update in place. So some resources in Azure, I need to flip a flag or just change a parameter or a property. It can maybe just update that in place. In other situations, it might need to destroy the whole resource and recreate it, because some of the fields that get set when it's created are then no longer editable once that resource has been deployed. So the only choice Terraform has is to destroy it and recreate it to get it to match your desired state. And we'll talk about how you can view that and see what's going on here in a couple slides as we actually get to, after you've got it configured, how do I deploy it? State can be stored locally, and that's great for just personal development or getting started quickly. But ideally and often in real enterprise production scenarios, it's stored remotely. So that's either in a AWS S3 bucket, Azure Storage, or in Terraform's own Terraform Cloud, right? And so if you've got multiple developers or CI/CD pipelines or things interacting and deploying your Terraform code, they can read from this state file. It's not like the state file lives on my machine. It needs to be somewhere that it can be read and accessed from multiple users or from a CI/CD automation platform or pipeline. And the state file uses a locking mechanism to ensure that only one Terraform process can update state at any given time. So it's got some built-in utilities to make sure that you don't have conflicting updates. So when I start a Terraform process, it's going to lock that state file and keep it locked until that Terraform process completes. So kind of a final slide here on just components and thoughts in Terraform. And this is not exhaustive. There are things in Terraform that you can get into, like for loops and local variables and all sorts of different function calls that you can do that really make it a powerful platform when coding. But at a getting started level, right, everything I've talked about, resources, the configuration files, are all you really need to get started. You should be aware that of these three items here: variables, data sources, and outputs. So the variables are declared in a configuration file, right? So I have to declare Terraform, hey, here are the variables that I'm going to use in my Terraform, my infrastructure as code configuration, right? And then you can set these at deployment time. And you can either do that via the CLI, where it'll prompt you, hey, I've got these variables, I don't have a default value for them, tell me what they are. You can have different environment or variable files. So per environment, you could have a TFVAR file for dev, TFVAR file for staging, TFVAR file for production, that sets different thresholds and different rules and permissions and performance levels depending on what environment you're going to, and use that. Or Terraform will look at machine environment variables that start with a TF underscore prefix, and then you TF underscore variable name. If it's got an environment variable on that machine that matches something that Terraform's looking for, it can use that. So this gives you a lot of power, especially in an automated deployment scenario, to release gate and set different variables and different settings without building or changing your Terraform code for those different environments. You just change the variables that are passed into that Terraform code to get you in the right configuration per environment. Data sources are another big one. These are references to resources that are not managed by your Terraform infrastructure. So we've had certain cases, especially on a permission basis, where I've come across it mostly, where the resource group with a resource subscription in Azure is locked down to where the people running it don't have access to just blindly create certain things, but a different team will go in and set up an environment with the right restrictions. But then I want to create resources underneath that resource group or underneath that collection that was already previously created. I don't want my Terraform to manage it, but I want to be able to leverage the properties of that resource group or that resource to create resources that I do want to manage. So this is where data sources come in. I can create a reference to something that already exists without my Terraform code actually creating it, destroying it, modifying it. And outputs, I kind of mentioned the return on a module. That's outputs, the way you do that. They're just used to expose values, usually after resource creation. So an example of Azure for IDs or domain names, it's going to create those on the fly as you create resources. If I need to then get that Azure generated ID back from that resource once Azure has created it, then I can use an output directive to get that value back after the resource creation has been completed. So let's talk about deploying with Terraform. So you've got your code out there, you've got everything ready to go. Let's actually deploy something. So this is all done via Terraform CLI commands, or called via CI/CD pipeline, scripted via Bash or PowerShell scripts, however you're writing your automation code. All right. But Terraform init, it initializes Terraform. And so the big thing that it does locally, if it hasn't done all this already, is it's going to download the specified providers and modules that you have in your configuration. So at the top level under providers, I've got to say, I want to use version 3.160 of the Azure provider. It's going to go ahead and go out and download that and store it locally, right? So it's got that provider definition if you haven't already downloaded it initially, right? And then it also verifies connectivity to the configured state storage location. So if I've got my state file local, it'll create state file locally. If I've referenced a AWS S3 bucket and Azure storage account, it's going to verify that it can connect to that and see that state file. If it doesn't exist, it will create the TF state file. If it can't get there, it's going to throw you an error when you try to do an init. Or if you've changed something about your state configuration, or you've changed the providers, you may need to actually run init with the reconfigure flag to tell it, yeah, I know, I want you to redo state because I've made some changes. Otherwise, it's going to warn you and say, hey, we've been using this state file forever. I can't get to it, or you've changed something. Are you sure that's correct? So the init is the first step. You really only have to run it once, or in a CI/CD, you might have to run it each time to make sure that the environment running your commands has the providers, has the connectivity to the state file so that Terraform can run. Terraform plan is what I talked about, of it using state in combination with what's been deployed to the cloud to come up with, what do I have to do to make your cloud infrastructure match configuration? So it creates an execution plan. And I'll show it to you. It shows exactly what actions Terraform is going to take to reach that desired configuration. It's going to break down in detail all of the changes. So this is where you'll see things like, this resource can be edited in place. This value is changing. The deployed value does not match your configuration. In order to get it there, I need to just update in place. Or your configuration does not match what's been deployed. In order to get it there, I need to delete that resource and recreate it in order to make your cloud environment match your desired configuration. Best practices here is, after your plan, you can output that to a TF plan file to ensure that future, I'll talk about the apply command next, to ensure that apply command only takes that planned actions. And also, if you then try to run an apply on a TF plan file after somebody else has already applied something, that plan file will now be invalid, and it'll catch that error that, whoa, wait a minute, when you planned this, in between when you planned it and when you're trying to apply it, something has changed. You need to run a new plan. And finally, the apply command, right? So it executes the actions proposed in a plan. And like I mentioned, if that plan has been invalidated by somebody else doing a plan in between, then it will catch that and say, hey, you need to do a plan. If you pass it, a TF plan file, it's only going to execute those actions, or as I mentioned, error if the state has been updated since the plan was generated. If you just call Terraform apply, it's going to run a plan first and then prompt you, do you want to apply this plan? So in a CI/CD, my strategy is always execute a TF plan, pump it out to a TF plan file, stage that for review. Somebody can look at that plan file and say, yeah, this is going to do what I want. It's not deleting resources. There wasn't some detected change that I wasn't expecting that's going to cause an environment to get deleted and recreated. And then assuming that review process passes, somebody clicks an approve button, and then we run the apply command on that plan file to make those changes. Like I said, it's only going to run the changes in the plan file that were reviewed, or it's going to error if somebody else had made a change. And then finally, there's the destroy command. And this, given your Terraform files, this will destroy all resources that are managed by that configuration. Cleans up infrastructure that's no longer needed. It's great for development environments or personal projects where I want to spin up something, or I'm footing the cloud bill. I want to deploy something, practice it, set it up, take a look what's going on, maybe do some application development, see where I'm at, and then at the end of the day, tear everything down so that I'm not paying for cloud resources that don't need to be lingering out there. Just a warning, this is a destructive action. Use with caution. This will destroy all the resources. It does the exact same thing, though. It will show you a plan and say, here's what I'm going to do. The plan is going to be a bunch of destroys. So keep an eye out and use this kind of with caution. So we've got a few minutes just before wrap up, and I've got a very, very quick just demo here. Were there any questions, Emily, that have come in through the chat before I just show this very, very short example and then wrap up with some Q&A?
Yeah, I have not seen any questions come through right now. So you're doing a great job with the explanation. I can see, as somebody who's not super familiar with terraforming, I know I'm walking away with a lot of good information.
Fantastic. I'm glad to hear that. Well, hopefully we'll further solidify it with this very, very quick example and simple example here. So let me pop over Visual Studio Code. So I'll show everyone quickly. This is just, I've got as simple as you can get this single TF file. I've mentioned declaring what version of a provider I'm going to use. So I'm pulling in HashiCorp Azure RM version 3.106.1. So this is I pulled this last night. It's the latest version at the time of this of the Azure provider. So it allows me to interact with Azure resources. Got some configuration options for that provider. And then I'm going to create a resource group. If you're familiar with Azure, kind of the base level container for resources in Azure. I'm going to create an app service plan. And you can see here, then I can reference properties of my resource group when creating the app service plan. All right, so I'm referencing the example resource group.name, example resource group location, giving it an OS type, giving it a SKU for that app service plan. And then similarly, kind of chaining this together in this Linux web app, I'm referencing the resource group name. I'm referencing, in this case, the app service plan location, and then the app service plan ID. And so this ID, as I talked about, the IDs getting generated by Azure, Terraform is smart enough to know that this resource depends on a property from this resource. So it's going to create these in the appropriate order so that those values are known when this resource attempts to be created. And then I'm using an output here to just output the default host name of this Linux web app so that I can navigate to it after I've deployed it to Azure. So I've already initialized here. I've taken step one already. So I'm just going to run a Terraform Terraform plan. So you can see what this looks like. And so again, this is looking at my state. In this case, state is local. It's going to look at my plan, look at Azure. It's going to say, you don't have anything out there. So I'm going to add 3 things. You see these green pluses. I'm going to add this web app. And here's the properties that are defaults. So I didn't pass all these. These are defaults that came in. I'm going to add a resource group. And then I'm going to add this service plan. Not necessarily in that order, but that's the action that is going to be taken. So the right way, as I mentioned, was to output this to a plan file and send it to apply. But I'll just show you here what happens if you run Terraform apply without a plan file. It's going to do that plan, show you again. Then it's going to ask you, sure you want to do this? And you have to type yes. So I'll give it the answer yes. And so it's going to go out there and start talking to Azure. It's going to start creating the resource group, start creating the app service plan, start creating the web app under that plan. You get then feedback of what that apply is doing and getting information back from Azure. So you can see that after 15 seconds, we successfully created that resource group. So now it's going to try to create that app service plan. And you'll see it, you get updates every 10 seconds about how it processed. Run this earlier. Hopefully it doesn't run long. Again, this usually runs in about 30, 60 seconds to create all of these resources. Obviously, depending on what you're creating, this could take a little bit of time. It should be similar to whatever it takes in the portal, or maybe even a little quicker since it's just directly hitting the API. So it finished creating in 23 seconds the app service plan, and now it's creating the Linux web app. So we'll give this a second to run through. And we should see what the expectation is after this, is once this web app is created, that output will fire and will show us that host name of the web app that was created. And once I get that back, we'll wrap it up for any questions that have come in. So I will just say what for personal projects, professional projects, if it's a cloud project, I'm starting with, first off, my code repository. Second is CI/CD pipeline setup so that I've got automated way to get my code and infrastructure out there. And then I'm starting with Terraform to build my cloud infrastructure, regardless of if it's a client project or something that I'm working on personally. Having this documented and coded in Terraform here has really made my life easier, especially on projects that I leave for 6 months and then come back to, and kind of run Terraform apply, and up comes all of the infrastructure and execute my CI/CD pipelines, and I'm back to kind of where I started, as opposed to if I went and point and clicked and set up an environment, 6 months later, I'd have no idea how I set it up to have things working. But if I've got it documented in here, it is a huge win and hugely beneficial, like I said, not only for personal projects, but for client projects as well. And just to prove everything, you see it did output my app fully qualified domain name. And if I pop this into Google and navigate to it, you'll see that the app is running. And if I look at my Azure portal here, you'll see example resources with an app service plan and my app service that got created in Azure. So as I share my screen or continue to share this and run a Terraform destroy, I will go ahead and open it up for any questions. So we got a small group here. If anyone has anything they want to add or ask, happy to answer anything.
I know you summarized kind of where you would get started. I'm curious though, how would you articulate the value of using this for maybe somebody outside of the IT department. I think a lot of us are in a position where we can see the value technically, but aren't always able to articulate that to people outside of maybe the immediate IT department as to what value this would add.
Right, absolutely. So the biggest thing for me is time. And with any of those processes that I mentioned, the source control up front, the CI/CD pipelines, and this Terraform infrastructure as code is, if I'm talking about this in a business sense, spend a little bit now to save a lot later. Uh, in the case of infrastructure as code, yeah, it takes maybe a little bit more time to get this all into a configuration file, as opposed to just somebody, hey, go set this up. But that might be the only your development environment. Great. And I've got to repeat that whole process to set up a QA environment. And I might not get it right. I might have differences between my dev and QA environment that some might intentional, maybe not intentional. And that could cause bugs as I try to promote a solution up, right? And so getting this in, the business value is, can we spend a week or a few days, depending on the size of the solution, getting this into the code, and then having the future deployments all automated with a consistent pattern saves so much time and energy. And your platform engineers, your developers can then just focus on adding features and enhancing the product, as opposed to trying to remember 6 months ago when we first started this, how was this set up, and trying to get it right again. The other big thing is disaster recovery and security recovery. In the event that you have a disaster, your environment goes down, you're the victim of some type of security problem, right? And you need to either quickly move or shut down or rebuild your infrastructure. Having this in code will get you back extremely quickly, as opposed to the panic mode of, oh my goodness, how was this environment set up? I now need to go remember that and go perform all of those steps that may have backed up over months or years to get to the state of where you're at. If that's not all documented and traced, trying to get back to that place is nearly impossible, or certainly extremely slow. Whereas if I've got this documented and I've got this in a repository and it's deployable and repeatable, I can hopefully click a few buttons and be back up and running with that infrastructure, as opposed to, again, trying to remember how it was created and redeploy all of it.
I think that sounds like a great selling point. Now, and you probably have addressed this throughout the presentation, but if I were to go ahead and say, this is definitely something that I want to move forward with my team, what kind of technical skills would we need to have available?
Yeah, so the nice thing is the technical learning curve for Terraform versus some of these other technologies that I talked about is relatively low. The documentation, again, at registry.terraform.io, is really robust, especially at the provider level, right? So that example of how to get a resource group out there, that code snippet is right in the documentation of, I want to deploy a resource group. Here's the code to do it. The technical background that I would say you would need to have is a team that understands the cloud environment they're deploying to, with enough knowledge to know what they need to deploy. So I keep throwing out, oh yeah, the resource group. Well, if you don't have a team that knows that Azure needs resource groups, or a virtual machine, we need to deploy virtual machines and how they're networked, that's going to be a base level of kind of technology knowledge that you will need to really take advantage of this. And that's where, if you're in that situation, improving can certainly help with the cloud transformation logic and cloud training aspect of it. But that's kind of where it needs to start of solution architecture in the cloud environment that you're deploying to. But as far as deep knowledge of coding languages or anything like that, it's really not needed to get started with Terraform, as the syntax is really simple, and all of the documentation of how to create specific resources and all of the properties of said resources is readily available. I'll say one final thought on that, that I've, even in Azure, just learning. One of the cool things on the documentation is, if I don't start at the resource group, if I go and say, I want to deploy some specialized resource, and I'll throw out, let's say, a Kubernetes cluster, right? If I want to go and deploy that, I can look up in the provider registry documentation the Kubernetes cluster resource. And in their example, it will show a full example all the way up to the resource group and any other dependent resources that are required in order to create that Kubernetes resource. So the documentation is incredibly powerful. It really can be as simple, maybe with some minor name tweaks to avoid collisions, of going to the documentation, looking at that example, copying that example into a Terraform file and applying it. And it will create everything needed, obviously not customized to your needs, but everything needed to get that resource out there. And you may learn something that says, oh, wait, in order to create a Kubernetes cluster, I need to have a special storage account that it can talk to. That's just an example that I could throw out there. But the moral story is some background knowledge of the cloud environment of which you're deploying, some architecture knowledge, but coding knowledge is a very light lift to start using Terraform to deploy infrastructure.
Well, it sounds like it's definitely something doable for a lot of people. Well, and you just answered my final question, which was, where can we find you? I know a lot of people are probably going to be interested in following up with this conversation. So I see you've got your improving email as well as your LinkedIn. I'd like to encourage everyone to feel free to reach out to John in the future if you have any questions or thoughts on the presentation. John, thank you so much for taking the time today. I really appreciate it. And as somebody who is not well versed in programming languages, I've always worked with my colleagues who talk about this a lot. And I love having a better understanding and a better ability for me to answer questions, to be a part of that conversation. So thank you so much.
Well, thank you, Emily. It's been a pleasure to be here today.
Wonderful. And I'd like to thank all of our attendants, our attendees. Thank you so much for joining at lunch. It is always hard to find time to continue to learn and grow. So I definitely applaud your efforts. I hope that you're able to take this back to your organizations and really help apply some of the items you learned. Just a reminder, Improving does these virtual lunch and learns every Wednesday. So feel free to join us again next week, June 19th, as we explore more of our platform and cloud engineering. Jonathan Kamara is going to be talking about speed and stability in today's market using the CI/CD pipeline. And his presentation, Turn It Up to 11, Turbocharging the CI/CD pipeline. I hope everyone is able to join us there. And again, thank you to our attendees for making time, and thank you, John, for giving of your knowledge. Have a wonderful rest of your day.